So let's continue the solution of quadratic equations by factorization method. So we have x squared minus 4x equals to 0. Because this quadratic has only two terms, then we don't have to struggle with product sum. We just consider the GCD of these two terms. So x squared minus 4x equals to 0 would be the same as x into x minus 4 equals to 0. Then using the zero product property for real numbers, this means that x equals to 0 or x minus 4 equals to 0. So therefore, x equals to 0 or x equals to 4 are the solutions of the roots of this given quadratic equation. For this other one, define product as 1 times minus 4, which will be minus 4. Sum as 3. So numbers, we don't struggle. Just write the product minus 4 and list its factors, plus or minus 1, plus or minus 2, plus or minus 4. And then take pairs, which gives you product of minus 4. So minus 4 can be given by minus 1 times 4 or 1 times minus 4 or 2 by minus 2. Now we check which of these pairs gives the sum of 3. So minus 1 plus 4 gives 3. So this really will work. 1 plus minus 4 is minus 3, so this cannot work. 2 plus minus 2 is 0, so this cannot work. So therefore, the numbers will be minus 1 and 4. So it means that we'll have x squared minus x plus 4x minus 4 equals to 0, rewriting the middle term using these two numbers. So this is the first pair, this is the second pair. Common here is x into x minus 1 plus 4 into x minus 1 equals to 0. So we'll have x plus 4, x minus 1 equals to 0. Now using the zero product property for real numbers, this implies either 0, x plus 4 is 0, or x minus 1 is 0. So which means x equals to minus 4 or x equals to positive 1 are the solutions for that given quadratic equation. So these are the solutions of this given problem. Number 3, we have 4x squared minus 25 equals to 0. This one has two terms, and you can realize that this can be written as 2 squared x squared, and 25 is the same as 5 squared equals to 0. 2 squared x squared is the same as 2x squared and then minus 5 squared. Now remember the difference of two squares. A squared minus b squared is the same as a minus b times a plus b. So which means that this can be written as 2x, or can be factored as 2x minus 5 multiplied by 2x plus 5. This gives us 0. So which means that by application of the zero product property for real numbers, either 2x minus 5 is 0 or 2x plus 5 is 0. Now, this implies that x equals to 5 over 2 or x equals to minus 5 over 2. So those are the solutions to that given quadratic equation. Next one, number 4, we have the quadratic y squared minus 5y plus 6 equals to 0. Now start by defining product, which is given by 1 times 6, which is 6, sum, which is given by minus 5. So we need to get two numbers that will give us this sum and product. Now we write what we have as our product and list its factors. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then get the pairs that will give you the same product. So we'll have 1 times 6, minus 1 times minus 6, 2 times 3, or minus 2 times minus 3. So these are the possible pairs that will give you product of positive 6. Now, we are interested in getting two numbers that will give us a sum of minus 5. So let's see which one will work. 1 plus 6 is 7, so this cannot work. Minus 1 plus minus 6 is minus 7, this cannot work. 2 plus 3 is 5, this cannot work. Minus 2 plus minus 3 is minus 5. So the numbers that work will be minus 2 and minus 3. So therefore, we rewrite our quadratic as y squared minus 2y minus 3y plus 6 is given by 0. Then do the pairing. So common here is y into y minus 2 minus factor 3, and then y minus 2, so that when you expand, this will be positive 6 equals to 0. So we'll have y minus 3 times y minus 2 to give us 0. So using the zero product property of real numbers, this implies y minus 3 equals to 0 or y minus 2 equals to 0. So therefore, y equals to 3 or y equals to 2. So these are the solutions to this given quadratic equation. That was number 4. Number 5. We have w squared equals to 15 minus 2w. Now, what you do in this case, you rearrange so that it is in the general standard form. So we'll have w squared plus 2w minus 15 is equals to 0. So that the product will be 1 times minus 15, which is minus 15, and sum is 2. So let's get the numbers. So our product is minus 15. So list the factors of 15, plus or minus 1, plus or minus 3, plus or minus 5, and then plus or minus 15 itself. Now this will give us either 1 times minus 15, minus 1 times positive 15, 3 times minus 5, minus 3 times 5. These are the possible pairs. Now we identify the pair that will give us sum of 2. Now 1 plus minus 15 cannot work. Minus 1 plus 15 cannot give us a sum of 2. 3 plus minus 5 cannot give us a sum of 2. This minus 2. So minus 3 and 5 is what will give us a sum of 2. So the numbers minus 3 and 5. So that now we write this quadratic as w squared minus 3w plus 5w minus 15 is given by 0. And then do the pairing. So this is the first pair, this is the second pair. So w into w minus 3 plus 5 into w minus 3 equals to 0. So w plus 5 times w minus 3 will give us 0. Now using the zero product property of real numbers, this implies w plus 5 is 0 or w minus 3 is 0, which implies that w is minus 5 or w is positive 3. So those are the solutions to that given quadratic equation. And then number 6, we have 3u squared minus 11u minus 4 equals to 0. So the first thing, define product, which will be 3 times minus 4, which is minus 12. Sum will be minus 11. And then we need to get the two numbers that will give us this sum and product. So let's write our product, which is minus 12, factors of minus 12 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and then lastly, plus or minus 12 itself. And then out of this, let's get the pairs that will give us a product of minus 12. So minus 12 is either 1 times minus 12, or minus 1 times 12, or 2 times minus 6, or minus 2 times positive 6, or 3 times minus 4, or minus 3 times positive 4. Out of these pairs, let's identify the one that will give us minus 11. So 1 plus minus 12 is minus 11, so that will work. Minus 1 plus 12 is positive 11, so this cannot work. 2 plus minus 6 is minus 4, this cannot work. Minus 2 plus 6 is 4, this will not work. 3 plus minus 4 is minus 1, this cannot work. Minus 3 plus 4 is 1, this will not work. So they will always usually be one pair that will work. So here we have minus 12 and 1. So we write this one as 3u squared minus 12u plus u minus 4 equals to 0. And then you do the pairing. Common here is 3u into u minus 4 plus 1 into u minus 4 equals to 0. So which means that 3u plus 1 multiplied by u minus 4 is equals to 0. Now this implies application of the zero product property of real numbers. 3u plus 1 is 0, or u minus 4 is 0. So which implies that u is negative a third, or u is positive 4. So those are the solutions to that given quadratic equation. And lastly, in this session, number 7, we have lambda 4 lambda squared plus 8 lambda plus 13 or plus 3 equals to 0. Plus 3 equals to 0. So solution for this product will be given by 4 times 3, which is 12. Sum will be given by 8. So let's get the numbers. So write the factors of 12. So factors of 12, 1 plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now 12 is the same as 1 times 12, minus 1 times minus 12, 2 times 6, minus 2 times minus 6, 3 times 4, and minus 3 times minus 4. Now let's identify those which will work. Now 1 plus 12 is 13, so it's not 8. Minus 1 minus 12 is minus 13. 2 plus 6 is 8. Minus 2 plus minus 6 is minus 8, so this will not work. 3 plus 4 is 7, this will not work. Minus 3 plus minus 4 is minus 7. So the numbers are 2 and 6. So this implies that 4 lambda squared plus 2 lambda plus 6 lambda plus 3 should give us 0. Now do this pair and pair this. Common here is 2 lambda into 2 lambda plus 1. Common here is 3 into 2 lambda plus 1 equals to 0. So this implies that 2 lambda plus 3 is given by 2 lambda plus 1 equals to 0. So using the zero product property of real numbers, this means 2 lambda plus 3 is 0, or 2 lambda plus 1 is 0. So this means that lambda is given by minus 3 over 2, or lambda is given by minus 1 over 2. So those are the two solutions for that given problem. So we'll give more examples in the next session. Thank you.